If you're gearing up for the Google Cloud Professional Machine Learning Engineer exam, you have come to the right place. Seriously, this isn't just going to be some high-level overview. Think of this as your personal blueprint for success. We're going to walk through the that's right, six core parts of the exam, and we're going to focus on what really matters, the concepts and the kind of thinking you'll need to pass. All right, let's jump right in.
Okay, first things first. What does a Google Cloud Professional Machine Learning Engineer actually do? The real key, the thing you got to remember, is in that word engineer. This isn't about just tinkering in a notebook to build the coolest, most complex model. Nope. It's all about building ML systems that are solid, robust, and ready for the real world. You know, production. And that right there is what the exam is all about. So if you look at the official guide, it paints a picture of the PMLE as a builder, someone who takes an idea all the way to production. This means you're wrestling with massive data sets, you're getting generative AI up and running, and you're writing code that can actually be reused. But, and this is a big but, it's also about working with teams and doing it all responsibly with responsible AI. So remember, the exam wants to see if you get the entire picture, the whole life cycle, not just little bits and pieces of the tech.
All right, here's our game plan. It follows Google's official exam guide to a T. Now, I don't want you to think of these 6 sections as just a random checklist. Not at all. Think of it as the real-world journey of an ML project, from start to finish. We're going to start with the big-picture design choices, and then we're going to follow it all the way through to watching over a live system in production. Let's kick things off with Section 1.
Okay, Section 1, Architecting Solutions. This is your very first decision point in pretty much any exam question. Before you even touch a line of code or look at a single row of data, you've got to pick the right tool for the job. And that's what this section is all about, making that smart, high-level choice right at the beginning.
This right here is a core skill for the exam. You have to be able to look at a business problem and figure out where it lands on this spectrum. An exam question is going to throw a scenario at you, and your job is to decide, can I solve this super fast with a pre-trained API or AutoML? Or do I need to roll up my sleeves and build a fully custom model? Being able to not just pick one, but explain why you picked it, that's absolutely critical.
Okay, so once you've made that big architectural choice, we move on to Section 2, Managing Data and Models. And let's be real, this is the foundation of everything. The exam is definitely going to hit you with questions about how to ingest, store, and process data on Google Cloud. Why? Because if your data strategy is shaky, the whole ML project, well, it's just going to fall apart.
When you're dealing with structured data, BigQuery is your absolute go-to. I mean, think of it as this massive, petabyte-scale data warehouse and analytics engine all rolled into one. For the exam, don't just think of it as a storage bucket. No way. You're going to use it for feature engineering, and you 100% need to know about BigQuery ML for building models right there with SQL. Super powerful stuff.
And for everything else, all that unstructured or semi-structured data, you've got cloud storage. Just think of it as your universal garage. Got images, videos, text files, even your saved model files. They all go here. It's the tough, scalable starting point for all the raw materials your ML projects are going to need.
Now, the Vertex AI Feature Store. This thing is a lifesaver because it solves one of the biggest headaches in ML ops, training serving skew. By creating one single place for your features, it makes sure that the logic you use during training is the exact same logic used when you're making live predictions. That consistency, it's everything, and it's a huge concept for the exam.
Which brings us perfectly to Section 3, Scaling Prototypes. You know, it's one thing to get a great result in a Jupyter notebook. We've all been there. But it is a totally different ballgame to build a tough, repeatable process that cranks out a production-quality model every single time. This is where the real engineering kicks in.
And the number one enemy you're going to fight here is something called, and you're going to hear this a lot, training serving skew. What is it? It's what happens when the data your model sees out in the real world is different from what it was trained on. Even tiny differences in how you prep the data can just wreck your model's performance. And trust me, this is a major theme on the exam.
So how do we beat it? The solution is to use a pipeline. See, tools like Vertex AI Pipelines, which uses Kubeflow under the hood, or TFX, they force you to define your data transformation steps as a separate, reusable piece. That same piece is then used during training and when you're serving predictions. Boom, you've just systematically killed that source of skew.
All right, so we've built a solid model artifact. Now we get to Section 4, Serving Models.
The big questions now are, how do we actually make this model useful? How do we get it into our apps? And how do we make sure it doesn't fall over when real people start using it?
On the exam, you're going to get a scenario, and you'll have to pick the right serving pattern. You need to ask yourself, is this a big batch job that can run overnight? Is it an online service that needs an answer in milliseconds? Or maybe it's a serverless container on Cloud Run. The right choice always comes down to what the business needs in terms of speed, cost, and how much traffic it's expecting.
Now we're leveling up. We're going from serving just one model to automating the whole darn thing in Section 5. Look, a real professional ML system doesn't need someone to manually retrain it all the time. The goal is to build automated pipelines that can retrain, check the new model, and push it to production without a human ever touching it. That, my friends, is ML Ops in a nutshell.
Let's make this super practical. Here's a scenario ripped straight from Google's own sample questions. Imagine your marketing team wants to send out emails every 2 weeks. You need to build an automated end-to-end pipeline that gives them the predictions they need, and you have to do it securely while keeping costs and maintenance as low as possible. Okay, so what do you use?
So when it comes to orchestrating a pipeline on GCP, it usually boils down to these two. Here's a simple rule of thumb for you. If it's a pure machine learning workflow, your first thought, your default choice should be Vertex AI pipelines. It's serverless, it's made for ML. Now, if your workflow is more complicated, maybe it involves a bunch of non-ML steps or has to connect with other data systems, then Cloud Composer, which is basically managed Airflow, is probably going to be the better tool for the job.
So for that marketing scenario we just talked about, the slam dunk, exam-ready answer is Vertex AI pipelines. Why? Easy. The problem describes a pure ML workflow. And what were the key requirements? Automation and minimal maintenance. The fact that Vertex AI Pipelines is serverless and managed just makes it the perfect optimal solution.
And that brings us to the final section, Section 6, Monitoring ML Solutions. Now listen up, because this is so important. Pushing a model to production is not the finish line. In fact, in a lot of ways, it's just the starting gun going off.
As a PMLE, you can't just deploy and forget. You have to be actively looking for trouble. You gotta ask, is my model getting worse over time? Has the new data coming in started to look different from my training data? Has the whole world changed so the old patterns don't apply anymore? Tools like Vertex AI Model Monitoring are built specifically to catch these kinds of problems automatically, so you can fire off an alert or even kick off a retraining pipeline without lifting a finger.
And there you have it. That's the complete blueprint. We've walked the entire journey of a professional machine learning engineer on Google Cloud. We went from architecting the solution to wrangling the data, scaling it up, serving it, automating it, and finally, keeping a close eye on it out in the wild.
So as you're studying, I want you to keep this one last question in your mind. The PMLE exam doesn't really care if you can just list off what services do. What it really tests is, can you connect all those dots under the pressure of the clock to solve an actual business problem? If you focus your studying on that skill, you will absolutely crack this code. Now go get 'em. Good luck.